The name of this talk is Use the Source Loop, High-Fidelity History with Event Source Data. That first part took me the better part of a night to come up with, so I hope you all like the title. Let's see, my name is Keith Gaddis. As of last week, I work for Spiceworks, who is one of the sponsors of RailsConf. This talk is not affiliated with them in any way, shape, or form, so don't hold them responsible for it. Yeah, that's kind of it. My contact info is there on the screen. If you can, you may not be able to read that. It's real tiny. Before I get started, let's see a show of hands. How many of you, or everybody raise your hand. Okay, if you hate ActiveRecord, put your hand down. If you have a love-hate relationship with ActiveRecord, put your hand down. Okay, the 5 of you left are excused. You can go ahead and leave. If you are somebody who thinks ActiveRecord is just the be-all, end-all of ORMs, God bless you. This is probably not the talk for you. So I'll talk a little bit more about my adventures with ActiveRecord later. Let's talk for a second about event sourcing and event source data. Fowler defines event sourcing as capturing all changes to an application state as a sequence of events. And what does that mean? So application state changes get encapsulated as events. So whenever your application state changes, a counter increments or something like that, that's an event, and there's some data associated with that event. An event encapsulates that, keeps it all in one place. What that lets you do is serialize and store these events. So now you have a history of the changes to your data. A lot of benefits come from that. One of them is that you can later recreate application state for any point in time. As you might imagine, there might be some performance penalties from trying to create application state this way, so we generally store snapshots of the data. And this is something that generally comes out of domain-driven design, and it's commonly used with a domain model. We think a lot of times of ActiveRecord models as being our domain models. For years, we've talked about things like fat model, skinny controller, and pushing all the domain logic into our ActiveRecord models. ActiveRecord models are not domain models. They are structural models. Nothing particularly wrong with that until you get into really complicated domains where structural models are kind of an anti-pattern because of some of the limiting factors of that. So we've got these events. The events hold the data that we need to mutate our application state, and we call that application. Applying the event changes the state in your data or in your application. And listeners are other objects that can also listen to these events and make changes based on those. Those are not themselves application state changes. That might be talking to an external service or persisting the events in some other form or fashion or something like that. So what are some of the benefits? We've talked about some of these, I think. So the events are your history of your data. If you only change state through events, then by persisting the events, you version controlled your data. That can seem a lot of times like it's going to be a really big data set. Okay, and it can be. The thing is you're not persisting the entire database every change along the way. So it's very, very fine-grained. And using these events, you can recreate the application state for any point in time. It's like time traveling through your data. For example, take account history. Anybody ever hear of like closing the books on the accounts and have to deal with the problem where you have to get your receipts in by the 31st day of the month, or you're not going to get reimbursed because they close the books on that day? And okay, so what happens there most of the time, closing the books just means they make a copy of the database on that day, and then they can't make any more changes to it after that. Anything that happens after that happens in another book month. The reason for that is they need to know what accounts look like at the end of that date. So, you know, one use case for something like this might be to be able to replay the events up to that book date, up to the end of the month, which you can then do at any point in time. So closing the books is no longer like a thing. We may still talk about it, but you can close the books at any point in time. So some of the other benefits, event sourcing means that you will only rarely have to say I'm sorry to the business people. Bug fixes become a matter of finding the problem in your domain logic and replaying the events so that the bug fix never happened. You can identify, when that's not possible, you can identify the points where the bug was an issue and add new events to correct state, much the way account transactions, you know, if anybody's ever had too much money deposited in their bank account knows the bank will eventually come back and make a corrective transaction on your account to get the money back out. You can do much the same thing when you have bugs or errors in data entry using event sourcing, because you have the history. You can see what happened in that, and you can, most of the time you can automate that kind of thing. Anybody ever had to try to fix migration errors or use migrations to fix data errors from a bad upgrade cycle or anything like that? Yeah? There's got to be more than 2 or 3 of you. Come on. This is Rails. All right, there we go. The honesty comes out. So that kind of thing gets simplified with this. Another really good use case, the one that actually brought me to this domain almost a year ago, was the use of heavy and complex analytics on your data. So I used to be the CTO for a medical billing startup. And anybody who's ever been to the hospital in the United States knows that this is a really complicated area. There's no such thing as a straightforward medical bill, and there is no such thing as a straightforward medical billing system. So there are some kinds of reports that these guys want that are pretty much industry standard. Everybody in the industry knows about them, but we were a startup and didn't have any particular domain experience in that area, and so we didn't know about them. And you know, going through a typical Rails you know, evolution of a product, we start off with really highly normalized domain models, or highly normalized active record models. We don't want to repeat ourselves. We don't want to store data in more than one place. We want to make sure there's only, you know, one point of truth in the system, blah, blah, blah. I don't mean to blah, blah, blah that, because that's all important stuff. But what it does lead to is the situation where some of the reports you need cannot be generated off of normalized data. You have to do something else in your application to reflect that data or project that data into a different structure, into a different form. And for some of these reports, if you don't do that as you're generating the data, you can't get it later. There is no do-over, there's no going back. If you didn't get it the first time, you just kind of screwed. For those kinds of things, event sourcing you're going to have to do it anyway. We don't call it event sourcing because the event is not the driver of the mutation, is not the driver of the change. Sorry, I have paranoid set on my screensaver. Anyway, so we don't call it event sourcing because the events are not the source of the data. But you're still going to use that event. I mean, that's what, you know, active record observers are all about, is reacting to some event in the system. However, by using the event as the source of change, as the source of truth, we can create a system that, you know, lets us echo these events out to different other systems and not muddy up our domain area with all of the extra changes we need to do to track, you know, data in this table and data in that table for one report or another. Another benefit from this is you're kind of prepared for the future. So in our case, we didn't know about this report we were going to have. This is a future requirement. Had we known about it, we could have prepared for it. But any application you start off with, you're going to have stuff that you don't know about. Has anybody ever had one of your business guys come to you and say like, oh, we need this now? Like, last week actually we needed this, but you're gonna need to do it right now. And you're like, dude, that would have been useful to know about like 2 months ago. Yeah, they do that to me all the time. So some of the other benefits. This is kind of one of those paternalistic things that we push in there, and that event sourcing is going to force you down a road where you actually have to model your domain. That means you have to know about your domain. You're going to spend, this is all stuff that we talk about we should be doing anyway, right? Like, we spend a lot of time thinking about active record models and whether or not this, you know, action belongs on this model or another. And I'll talk more about that in a little bit, but you know, one last benefit comes from system decoupling. So by pushing all of the domain logic into a set of models that are just Ruby objects and modeling your business behavior there, we've now pushed all of our non-business logic, stuff like talking to, you know, in my case, we were talking to healthcare clearinghouses about billing data. That stuff doesn't belong in your domain objects. It's not part of your business logic. It's part of the business requirements in another area. But we can decouple that through this mechanism. So some of the drawbacks. As you might imagine, there's this question of overkill. You know, is this something I really need right now? If you're early in a product development cycle, if you're an early stage startup, you probably don't. You know, I've used this now in a few different places, and I can tell you that there's some cost to it. The first one is that, like I said, it forces you to really analyze your business domain. It forces you to really analyze your problem, to know, you know, what it is that you're dealing with and talking about. The problem with that is it's not always clear what we're dealing with or talking about. When you're in a startup, you are very often creating your domain. You're creating a new problem, you're creating a new area of business. And so it's not possible sometimes to analyze your stuff. So early in the product development, you know, as I mentioned, the domain may be unclear. There's also a bit of an agility trade-off. In that early stage, you want to be able to move quickly, and this is going to impose some, you know, constraints on you that may not make it easy to move that quickly. It's not necessarily a reason not to do it, but it is something to keep in mind, and you have to weigh the trade-offs. You know, as I mentioned, it's something that can really enable you to do some stuff with crazy analytics far into the future, you know, on data sets that go far into the past. And that's really great. It may be that that's an overriding, you know, concern for you. Or time may not be your enemy. You know, you may have just tons of funding, or you may be working on something on the weekends and funding doesn't matter. But there is kind of like this agility trade-off when you do this stuff. You know, this is something that's come out of managing complex business systems and you know, really heavy-duty domains. And, you know, consequently, it's okay to move a little bit slower on things. So another drawback is can be performance. In some areas, it's common to have really large event logs. Think about like a stock trading kind of domain where, you know, millions of trades happen even in a day sometimes. And so trying to replay all those events to get to the end state would be, you know, performance heavy. So what do? We store a snapshot of the domain models. And there's a few different ways to go about that snapshotting process. But the end result is that we don't end up playing all of the events forward in the snapshot. You know, we may go up to a point, stop here, and then play events up, you know, past that, and then roll back and forth to a different snapshot date. You may snapshot every time a new event comes in because you're doing it all offline and there's no performance penalty to that. I really like Active Model for this reason. There's a lot of good stuff that's come out of Rails and ActiveRecord. Active Model is one of my favorites. It gives us some, really easy to use hooks into stuff like serialization and defining properties and things like that on models. So there's some common use cases to event sourcing. One of them is source control. Nobody in here uses source control, right? Well, just making copies of our directory and storing it on a hard drive. No, that's so 2000. Yeah, so source control, every commit is an event. Whatever commit you've got checked out, that's your snapshot. You can jump back and forth in the history of the project and recreate it at any point in time by checking out different commits. Another really common use case of this, as I mentioned, is financial and accounting systems. These are domains where you absolutely, positively cannot screw up. You absolutely, positively have to be able to prove at any point in time how you got where you are. If you don't, federal people are going to want to come talk to you, and they're not nice. Well, that's not true. They may be really nice people outside of their professional life, but usually if they're coming to talk to you about this, they're not going to be nice about it. Really complex domains. These are too numerous to even lay out there, but if you have to go to college to deal with this domain, it's probably complex enough that you would, want to think about this. Stuff like accounting, but also, engineering, medical applications, medical domain kind of stuff, all kinds of different areas. And as soon as you try to boil it down to one or another, you'll think of 10 more. So this also plays well in distributed systems. Events are a great way to syndicate what's happening in your business domain to other systems that need to deal with that. For example, reporting systems. All right, so let's look at a little bit of a code example. This one's real simple. It's an ordering system. Orders have line items, and line items all have a SKU and a price. So a lot of times in domain-driven development, we don't talk about models, we talk about aggregates. An aggregate root is for all intents and purposes, kind of like an ActiveRecord model. And any aggregates underneath that aggregate root don't make sense on their own. So it's kind of this tree of things. For example, in the case of an order, a line item by itself doesn't make sense. It doesn't really have any meaning. It has to be attached to an order. So this is how this next section of code, the next several slides, are all just plain Ruby. There's nothing special about them. We've got an order. It's got the order ID, an accessor for our line items, which will end up being a collection. You initialize a new order with the order ID. The reason for that is when you're playing events back, all of those things need to get tied back to an aggregate root ID. So you can't let the database generate your IDs for you. You need to do that on your own. A lot of people use GUID systems for that. There's different ways of doing it, but the bottom line is that if you don't do that, then you're not going to have kind of the starting point to play events forward from and have them all tied back to a single ID. And then further down, we've got the line item, which is just a SKU and a price with the related initializer. So then we've got a couple of events. These, again, are just plain Ruby objects. The line item added event is going to take a SKU and a price and a time added. Same thing with the initializer, and then the line item removed event just needs a SKU. So we're just going to remove the line item that matches this particular SKU. In reality, that's probably a bit simple, but I wanted all the code to fit on one slide, so we left out details. All right, and then commands. Commands, for the most part, are just method calls. You're sending, some instruction to the object. We've got a command for add line item. It's going to take a SKU and a price, and all it's going to do is create this new event for line item added, and then apply it to itself. Similarly, the remove line item is going to create this event and apply it to itself. So the application of events is, this is kind of the key point, is what are we doing here that makes all this kind of work. So we take an event. We want to store the event. Serializing it and storing it's kind of a big deal when you're doing this stuff. And we're just going to use Redis. The Redis initialization code is not listed here, but it's all pretty simple. And so we're just going to push it to a key that's based on the order ID and serialize the event itself into YAML and store it as a string. It's real simple. Then we've got a very naive application of the event, and we're just going to do an if-else kind of series and take action based on that. So the nifty thing is rebuilding this. If I've got an object and I want to rebuild it, I'm just going to pull the entire history of events. So this is a Redis list, and it's going to be ordered in the order the events came in. And so I'm just going to pull back all the events, map them back into their event objects, and for each object I'm going to reapply that. So something to notice about this application process is there's not any logic going on once I get inside the block of application. Once I've have picked out this, I don't know if that gets highlighted. Yeah, there we go. Inside these lines here, there's no decision to make. The event happened. That's a point of truth. And so there is no, if the event's like this, or this value or something like that, there is no decision tree there. You're not allowed to change history. And so the application part is real simple. And that's what allows us to, have this rebuild section where we iterate through all these events and just keep applying them one after the other. We don't have to do anything, save the object in between or anything like that. And so we can do that pretty quickly. So once we put this stuff into action, we're going to create an order, add 3 line items, print out the order total, remove a line item, print out the order total again, and then rebuild the object. And down here we see the output. So the first time around with 3 items, we've got the order total is 6. With 2 items, it's just 4. We've removed the second item, which had a value of 2. And then we rebuilt it and ended up at the same spot with a $4 order. There's nothing particularly magic about that. We just walk through the code, and it's pretty simple and straightforward. So that brings us to replay. Replay is a gem that I've put together and been working on for a little while that facilitates this process of event sourcing. It can handle the event storage for you and the application of those events back to your domain models. It also gives you an easy way to let other objects listen for those events. So this is useful just by itself if you're just doing event sourcing, or even not using event source data, but just using events. But it's also useful as part of a CQRS architecture, which we haven't talked about CQRS yet, but I'll mention it briefly in a few slides. So using a replay is pretty easy. You just require the gem, And then we're going to include this replay domain module inside of your pure Ruby object. Notice this doesn't inherit from ActiveRecord or use SQL or anything else. This is all just plain Ruby. And where we had an if-then, if-else process before, now we've just got these application blocks. So we tell it what class we're interested in applying for, which event we're interested in handling with this block, and we do that. We don't need to save inside the block. We don't need to do anything special in there other than mutate our state as necessary. So we do that for the line item removed event as well. And then down here where we had our commands before, we still got our commands, but all they do, can y'all read that okay with the blue on black? We use the signal event method to raise the event, and that lets replay do the magic with persisting the events and that sort of thing. So not any earth-shattering differences, but just a little bit simpler syntax and process there. So the line item event, the line item is still a domain object, plain old Ruby. The difference is now we're using property instead of attr accessor, and what that does is allow you to use each domain object is also active model object. So this actually uses a gem called ActiveAttr, I believe. It came out a month or two ago, and that lets me serialize these domain objects into JSON really easily. And so our events are also going to end up being active model objects. They similarly have properties that we can define on there. And then finally we have listeners. So again, a pure Ruby object. And we'll use this listen block to decide which events we want to listen for. In this case, we have an order completed event, which is not one of the events we talked about before, but as you go through the ordering process and the user's done adding things to their line item and you complete the order, something's going to need to send that off to the warehouse. So that's kind of where the listeners fit into the picture, is that they handle those non-domain processes that need to get fit in there somewhere. And this lets you, really decouple your those pieces of logic from each other. So one of the things that this kind of fits into, plays well with, is a notion called DCI. And DCI stands for Data Context Interaction. Anybody here, raise your hand if you've heard of DCI before. Yeah? Ah, good group. Yeah, so some of these ideas, they actually come, more heavily from like kind of an enterprise world. And I learned about this stuff from a bunch of .NET guys. It's also used in the Java world as well. But until the last year or so, it's not something we've heard a lot about in the Ruby world. Those of us who have backgrounds in other areas have probably heard it before, but it's not something you certainly don't see a lot of it in the Ruby world, even if you have heard a lot about it. And that's starting to change. I think I've seen a lot of talks this year and things like that on some of these other areas like DCI, domain-driven development, CQRS, that kind of thing. So the idea behind DCI is that we separate our domain models, or our data, from the use cases, which is the context that the data is being used in. And we do that, we allow data to be used in a context using a role, which is the interaction part. So roles are modules that, in Ruby, that is, are modules that define the actions or commands. So where I have an order that has its SKU has its line items and order ID, that's all the order would be. Then I add a role to the order in the proper context, so the user is finishing off the order, and that role would define the methods for completing the order. So this lets us separate domain behavior from domain data. And in Ruby, we typically mix these in either to an instance so that it's not mixed into the class as a whole, or we'll use a method of composition to add the role to the data at runtime. That's really all I want to get into with the DCI stuff. This is a really interesting area to start delving into if you feel like you have tightly coupled application logic. This is a really good way to start analyzing it and looking at how you might want to factor that stuff out. So another thing this plays well with is something called CQRS. And before I get into that, it comes out of this design pattern called CQS, which Bertrand Meyer wrote about a long time ago. And it means command query separation. The idea is that a method should do one of two things. It should either return a value, in which case it's a query, or it should mutate state, in which case it's a command. You don't want to mix those two things up. It's part of the single responsibility principle. So CQRS stands for Command Query Responsibility Segregation. There's a couple of guys that are real big in the DDD world, Udi Dehan and Greg Young. And this kind of carries the CQS idea over to a systems architecture area. We use domain models for maintaining application state. This is where the event sourcing fits into things. Then we have another set of models that are the read models. So those read models would be peculiar to whatever use they're having in the system. So it's a bit of hand waving, but so you might have one set of models for your application, like your order stuff, but then you have another set of models that deals with the reports around your orders and how many line items of this type did we ship a month, or how many doctors killed how many patients this month, or whatever crazy business reports they can come up with. And then we use commands, which in a CQRS architecture, a lot of times you'll use command objects. The command doesn't just represent a method call. You'll wrap that method call in an object that will handle responsibilities like validation, backgrounding, moving it into a message queue, that kind of stuff. So get it kind of out of the request cycle that way. Then these commands then generate events, which are mutate the state of your application, and we can also use those to syndicate the actions to distributed systems. And a real good way of doing that is with message queues, RabbitMQ or ZeroMQ, Rescue, message queues like that. Another good thing about using commands like this is it's real easy to test. You can just run the command in your test and check to see which events come out of the command. You can do this with your methods as well, but it's kind of a BDD approach to this stuff. You don't have to worry so much about how the events get applied. You just want to make sure that those events got raised. So later on, when you have to change the implementation of those events or the application of those events, your tests are not so tightly coupled to the events or to the behavior itself. So if you're interested in more info about this, Martin Fowler's got a really comprehensive article on the subject of event sourcing. It's kind of dense reading, as a lot of his stuff is, but the thing about Fowler is he's real smart. So there was this kind of aha moment I had a while back where I was reading through Fowler's article, and it's like, event sourcing is hard. And I said, it's not that hard. We've got the code here and it all works well. And so from that experience, I've formulated a few rules. One is that you are not smarter than Martin Fowler. The second one is that if you think you're smarter than Martin Fowler, go back and read rule number 1. Event sourcing is kind of hard. you really have to sit there and think about what you're doing for a long time, and it helps to actually know something about the real world process. The reason I like this area so much is because most of what we do as developers is modeled on the analog world. When we store data in a database, when we use ActiveRecord as the primary knowledge repository, use a database as the primary knowledge repository. I mean, ActiveRecord is just a conduit for that. The problem is that we're limiting our vision to what the database supports. And that's just a shadow of what actually happens in the real world. You know, object-oriented development has been around for a long time now. And we've got a lot of techniques that we can use to model the things that happen in the real world. But when we limit ourselves to structural models, to the use of database models, we do a real good job of kind of constraining our vision to what that supports. Have you ever had a join model that you call something that has absolutely no relevance in real life? We used to have one we called provider payer, which represented the link between somebody paying a medical claim and somebody providing the service. And if you talk to somebody in the medical industry, they're like, I don't know what that is. You know, when you have that kind of disjoint between the people who know this industry and the code that you're writing, it's a pretty good sign you're taking something too far. You know, it's a good anti-pattern. And so that's kind of the path that led me over to this stuff. So there's a lot more info about domain-driven design in a book called, ironically, Domain-Driven Design by this guy Eric Evans, who is also, you're not smarter than him. And the last link is my website. It's not authoritative on this stuff or anything like that. Don't go there looking for knowledge. I just blather on from time to time. So anyway, we're getting close to, yeah, I managed to talk longer than I thought I would. So any questions right now? Sure. So the question was, on the systems I've used event sourcing, have I also gone down the path where I used a database that was tuned for the queries? Is that right? So like the specialized kind of queries, yeah. And the answer to that is yes and no. I have definitely gone down that road and done it. Whether the code actually made it into production before the startup went under was a different story. But the code is definitely, I've definitely gone down the road, and I found it really simplified things in a lot of ways. The bigger win for me on that project in particular was being able to go back and recreate the data structures. The thing is putting this into a project that wasn't there in the first place is real hard. But sometimes you'll find yourself back in a corner where you have to refactor this. Like you cannot deliver some critical feature without going through a refactoring process. And when you're in that spot, if you've got to do like a major overhaul of your internals, this can actually be a simpler way to go about it. I've been through that cycle before, and if I had it to do over again, I think I probably would just remodel it using pure Ruby objects and then add in the event sourcing that way, rather than try to do migration after migration after migration where we try to fix our data and get nowhere with it, or create ourselves all kinds of headaches out of that process.
What about the object graph changes in terms of like migrating your event source?
What about the object graph changes in terms of what?
Well, if your object graph changes, or if your domain model changes, and you've got that event source of data in it.
So the biggest change in my case was dropping these extraneous join models that ended up having a lot of application logic based on them. We had a lot of app logic that was kind of keyed off of these join models that really didn't represent anything at all. They were just there as a link between two objects. And when you model that with pure Ruby objects, it's just a matter of composition. I can just add what I need to a collection and it's all kind of like lives right there in the object in question, rather than being strewn across 3 or 4 tables. I mean, like, when you're trying to do reporting on something like that, I think the gnarliest query I ever had to write involved a join between like 11 tables and like these kind of weird double backward join, you know, kind of stuff. And anybody who's had to do this kind of reporting probably knows what I'm talking about, but it's, you know, really, really hairy to do when you're dealing with structural models in a database. You know, the flip side is that now I have to come up with a way to model this stuff without using, you know, or something that's more tuned. And sometimes that can be a thought process in itself. It's like, okay, so what is my ideal model or ideal database structure for this stuff? And that, you have to learn to think a little bit differently to hit that question. So, who else? Yes.
How do you ensure that as you change code, that your old events are still replayable in the state?
Okay, so there's a few rules about events. First of all, my code example shows this serializing this as YAML. Don't do that. That was simplicity. I meant to point that out when I was going through the code. Use an independent format like JSON or something like that to echo this stuff out. And ultimately, your events are just data, right? They don't model any behavior. They model the data that was used to affect the behavior. So the first rule about events is that when you come out with new versions of events, they can only add. They can't take away what was there before, right? So that means when you're migrating up, that all it's done is add data and had all the other stuff. However, if you take stuff away that was required before, then it doesn't go the downward path, right? So you don't have a way to go back down. I don't know if I'm making sense there. In general, I haven't found that to be much of an issue in the places I've used it. That said, I'm also not I'm not the guy who invented this area of research or anything like that. So somebody else's experience may differ a little bit. But in general, if you make sure that the changes you make are mostly additive and not subtractive, then it won't be much of an issue. Yeah.
So I noticed you played back a targeted sequence of events for a product, or for an order.
Sure.
Do you find that actually works in practice, where people run into problems like an event targets multiple things, like it's a product and an order, and how do you key an event?
So the event has all of the data, has to have all of the data necessary to apply the event, right? So I haven't had any experience at all where, so rather than, now we're getting a little bit deeper into DDD stuff. So we have these things called a bounded context and, aggregate roots and this stuff. And so, in a place where like I might be adding an order, you wouldn't really add the order, you'd add the order ID, right? And so it's not wholly necessary. Let's take the example where I'm adding, the event needs to have the order total or something like that. That would have to be sent into the event, not calculated in the application block. Does that make sense? So it kind of knows it going in there. I'm not sure if that's answering your question or not.
When you sort in Reddit, you store it with the order ID, but that order might actually touch the product. You might want to store it with 2 different names, so you can replay all the events in this product, all the events in this order.
Yeah, so the events are always tied to a single aggregate. So what I'm concerned with there is the events that go with that order, and not any events that are, if the product, would need to know, but that's a whole different command, right? And so that's going to generate events for that thing. I don't send off events to other aggregates from the one in question. Does that answer your question better? Okay. Get back.
Ever come to deploy like data objects, and I find that difficult because with the serialized data, you've got the serialized string of events, and you have to figure out which event to just change the data as an object.
I haven't run into that. It certainly could be a problem. And what that's going to come down to, because, all right, so what we're used to with databases is being able to introspect the composition of an object in any, way, shape, or form. So, you still have a database, right? And this is not to take the database out of the question. The database is a perfectly legitimate way of reporting on your data and figuring things out. And so, a lot of times the first thing you want to do is set up, listeners that create the database for you off of this stuff. You just don't want it to be the primary repository of truth. In this case, assuming I had, some kind of a database echo of this stuff, I'd look for the data there. I might also have, something like a Lucene search index on my models that I use to query against them. You're still going to need some method of querying against them. This doesn't make that go away. It just gives you a little more flexibility about how you do that.
I just wanted to progress with you and sticking with the data design. Do you kind of encapsulate the serialization behind the logic pattern, or?
Yeah. So, if you go look at replay right now, it's got some stuff I need to push up. Sorry, the question was, is there some encapsulated kind of persistence and that sort of thing involved in this? And my answer is in the gem itself, replay, there is the provision for that, an event store that lets you get the events for a particular aggregate and to add stuff to that. It's also real easy to write one, so I think I. Sure. So one thing we didn't really talk about was validations, right? And that's usually the problem that you run into for that. Oh, yeah, I'm sorry. I'm real absent-minded. The question was, he's having trouble visualizing how you would replay events for code that's 100 revisions old or older code. And so the problem usually with older code is going to be something like validations, right? If you've ever tried to run your entire migration path from the start of a project to the end, you almost always will run into some place where you've now added a business constraint that doesn't work anymore. The other thing that you'll run into besides validations is the event migration problem, where we've added new data to an event or subtracted data from that. And so that's the part of that rule, is that you can't subtract data from an event as you move up, through its evolution. You can only add to it so that the old events still apply. If you do, it's a new event. And so, it's not altogether, you'll certainly have new capabilities added to it, but that's the rule about applying events, is that they happened, right? That's the one incontrovertible thing you can't do, is pretend that this event didn't happen. And so, let's say that I have, one of my models is a user, and at some point I decide to add a constraint that a user has to have a unique email address. Well, if I were doing this without event sourcing, that's still a problem. Until I add that validates uniqueness of, it's possible I'm going to have more than one user with that email address in the system. And really the question is, how do you resolve that issue? And that's a business question. That's not a code question. It's, do we email that user and say, hey, we've got two objects for you here. Which one do you want us to use? Do we merge those into, these are questions that have to be answered kind of at the business level, not at the code level. So, you can't really get away from that one. But does that answer your question? Kinda. We can talk more about it offline. We're about to run out of time, I think. So, yeah, one more.
Yeah. Is there implementation difference between the apply and the replay of the event? That apply would do some kind of persistence change in the database, and replay would be just like what? Spitting out the log and like.
Yeah. So the question is, there a difference between the application and rebuilding? And there isn't one. The only difference is that rebuild is going to apply all of the events in sequence. So apply is the unit of rebuild. As we move from one version to the, one mutation to the next, the application of that event is going to do the mutating. And so when I rebuild, all I'm doing is apply, 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 apply. You see how that works? I mean, there is, so when I signal the events, maybe that's what you're wondering about. When I signal the event, yes, there is stuff that happens in replay. It'll persist the event for you and then send it down to the objects that care about it, the listeners and the aggregate itself. Does that make sense? Okay. All right, I think that's all the time I've got. I've gone over a little bit. So.